So 4-2 has a lot of previous knowledge in it, so I'm going to kind of zip through that. However, I'm going to give you some good ways to memorize things. The whole front page is stuff that you should memorize. Now, I'm not really big on memorization if you know how to derive it or where it comes from. So let's just start with the top here first. So you need to know all 6 of these trig functions and their ratio relationships. This is your angle of reference right there, and that these are the sides that are opposite, adjacent, and the hypotenuse to that angle of reference. These only occur in right triangles. So if you don't have a right triangle, you're most likely not using sine, cosine, tangent, and their inverses. So how do we remember them? Don't have your parents call and complain about this. It's just something that keeps in your brain. So some old hippie, especially if your mommy or daddy's a hippie, don't take it personally. So S is for sine, O is for opposite, H is for hypotenuse. So some old hippie. That's how you remember your ratios. Then for cosine, we've got cot, another hippie. Yep. C is for cosine, A is for adjacent, H is for hypotenuse. And then for tangent, we have tripping on acid. It's not to say all hippies did that. Don't take it personally. So T is for tangent, O for opposite, A for adjacent. So you can just keep running that through your brain to kind of remind yourself of what the ratios are and what order that they go into. Or you can come up with your own mnemonic. It's your choice. Now, what do you notice about sine and cosecants? What do you notice about these two? Yeah, they're reciprocals of each other, aren't they? Same thing with cosine and secant and tangent and cotangent. Now, somehow you have to get in your brain that sine and cosecant are inverses of each other. I realize that cosine and cosecant seem like they should go together, but they don't. So that's the one thing that you have to have solid in your brain is that, okay, sine goes with cosecant. So however you want to do that, that's the one thing that you have to figure out on your own. All right, so then we have special right triangles, which you started with in geometry. Look at that's fuzzy. See if I can make it clear. Oh, just a little bit. All right, so in geometry, though, you had side, red 2. And in Algebra 3-4, you were introduced to something called the unit circle. What's the radius of the unit circle? Well, if that's my central angle, and this is created from the unit circle, nope, I want my radius, not my degree. Rad 2, okay, well, technically, yeah. But no, I see where you're coming from. Our radius is actually 1. But I see what you're coming from. Well, when we do it in the unit circle, you'll see how I come up with Rad 2. Well, when we get to the unit circle, it'll all come around and make perfect sense. So, when you hit Algebra 3-4, you're introduced to that unit circle, and the radius of the unit circle is 1. True? Okay. So, on here, because this is an isosceles right triangle, this is an unusual one. We've got 45, 45, 90. So, you'll hear me refer to it as this. That's the name of that triangle. You have to know this triangle. So that, yeah, you have to memorize that. However it takes for you to memorize it. You got 1, Rad 2. You use it enough, you start to learn it. You don't have to memorize it, because you just start to know it. You will see me drawing this every single time. I do not memorize the unit circle. I derive it by my special right triangles. So if you don't like to memorize, you can derive the whole thing using special right triangles and then just reflect for all 4 quadrants. So that would be my suggestion, because I don't memorize anything on there. I just reflect. And so for your 30, 60, 90, oh, by the way, this is your angle of reference. And since they're both 45, it doesn't matter which you use. But I like my angle of reference on the ground, so to speak. And so for this one, this is your 30, 60, 90. Notice that across from your 30 degrees is 1. Across from 60, and 30 is the smallest degree out of the entire triangle, so it makes sense that it would have the smallest side that it would be across from. 60 degrees is across from radical 3. Radical 3 is actually smaller than 2. But out of these two numbers, isn't 60 the bigger one? So it might be helpful for you to try to remember what's across from what. That rad 3 is bigger, appears to be bigger. Most of you would try to tell me that rad 3 is bigger than 2. So I like to remember that 60 is across from the biggest one that it appears to be, even though technically it's not. Notice that all of your hypotenuse are some form of 2. And so that's another way that you can help remember where that 2 is. The 2 is never on the leg. It's always on a hypotenuse. And so we've got 1, rad 3, and 2. Now, this triangle and then this triangle are exactly the same triangles. I still call this a 30, 60, 90 triangle. But your angle of reference has now switched. So your 60 degrees is down here. Isn't the 60 still across from radical 3? And the 30 is still across from 1. And your hypotenuse is still 2. But again, we like to look at our angle of reference as here at the ground. The other thing that you do have to know, and again, I don't memorize it, but you have to know that 60 degrees is pi over 3. The easiest way to derive it is we're taking pi and dividing it by something. Isn't pi 180 degrees? What's 180 divided by 60? 3. So it's pi divided into 3 pieces. So it's pi over 3. What is 180 divided by 30? 6, pi over 6. And then 180 divided by 45, well, if you think about it, there's 2 90s and 180, and each 90 has 2 45s. So there are 4 45s and 180 pi over 4. So somehow you have to know those 3 angles as well. Seth? Say that again? You'll see that later. You don't have to deal with it today, but you should have learned it in Nelson's class. I know she taught it. Yes, she did. Don't freak out about it right now, because you're not having to know it yet. So take a deep breath. All right, so let's look at example 1. All I'm doing, Seth, is laying the foundation for your unit circle. And you're going to use this information right now, and then we're going to apply it to our unit circle in our next lesson, which will be 4-3. So example 1 asks you to find the 6 trig functions that we just saw above for an angle of 45 degrees. So we're going to use, I'm going to zip out here a little bit. So we're going to use our 45, 45, 90 triangle. So I've got sine of 45 degrees equals, and all I'm going to do is apply my ratio. So some old hippie, opposite over hypotenuse. So it's 1 over radical 2. Now, what you're going to find out is as we hit pre-calculus and calculus, they start to accept, they meaning the higher mathematicians, they start to accept that as an answer. What did you learn in algebra 1, 2, and 3, 4? Can't have a radical in the denominator. So as an algebra teacher for years and years and years, this is like nails on a chalkboard. I don't like accepting it, but I will recognize that Math Excel and or the answers in the back of your book might actually have that as an answer. If we rationalize this, the proper answer, in my opinion, and what you'll see in your unit circle when we get there, looks like, whoops, not 4, would be rad 2 over 2. That's the actual proper answer, but I will accept this grudgingly as an answer. Yes.
So what stops you from making that 2 over negative 1/2 and just bringing it up to the top?
What do you mean 2 over negative 1/2?
Well,
oh, I see what you're saying. We don't want to do that because we don't want negative exponents or anything like that. I see what you're saying. But yeah. No, don't do it that way. Because then you'll end up getting, it becomes more complicated. But it's a good question. Are we good with that? All right, so then we're going to find cosine. So cosine of 45 degrees, and notice I'm writing cosine of whatever my degree is each and every time that I write it. Isn't cosine, which is adjacent, the 1 or the radical 2? The 1, because it's leg adjacent, not the hypotenuse. So this has the same leg as the side that's opposite. So you're going to find that the cosine and the sine of 45 degrees is identical. And then your tangent of 45 degrees, tripping on acid, on opposite, acid adjacent. So isn't it 1 over 1? But we don't want to write it that way. Its true answer is 1. So I will not accept 1 over 1 as an answer. So then we're going to find cosecant, secant, and cotangent. So all they are inverses or reciprocals of each other. So cosecant of 45 degrees. I do like to look at the unrationalized form when I'm finding my reciprocals, because if I take the reciprocal of rad 2 over 2, don't I end up with a radical in the denominator, which technically I need to rationalize. I will guarantee you that Math Excel will not accept 2 over rad 2 as an answer for cosecant, because technically you should be taking this one and flipping it, and don't we get radical 2? No work to be done for that. Same thing with secant of 45 degrees. We're going to take the reciprocal of that, and we get the square root of 2. And then what for cotangent is the reciprocal of 1? What's the reciprocal? It's still 1, isn't it? So the 45, 45, 90 triangle is weird. A lot of the things in there are the same. A lot of the trig functions are the same. It's the only one that you're going to see like that. So then let's look at part B. We are going to find the 6 trig functions, and you're missing this part, for an angle of 30 degrees. So you're looking at this triangle right here. So I want you to find the sine. Well, let's go ahead and look at this anyway so we can talk about things that we'll reduce, and I'll let you do some stuff in here. So we've got sine, and we're doing 30. So I like to look at this triangle, not this one. So 30, some old hippie. What's opposite to 30? 1, and hypotenuse is 2. So no rationalizing needed. And then cosine of 30 degrees. Caught another hippie. So adjacent is what? Radical 3 over 2. And then tangent of 30 degrees. Tripping on acid is opposite 1 over the square root of 3. Technically you need to rationalize that. Rad 3 over rad 3, which gives you a final answer of radical 3 over positive 3. Then I want you to find cosecant, secant, and cotangent, so you find the reciprocal of those and use the proper item to take the reciprocal. So come up with those on your own. So when you get those answers, I want you to share them with somebody around you to see if they agree with you. You might have a disagreement with one of them. So everybody share. Somebody's got to talk to somebody. Don't leave anybody out. Quince, what you doing, babe? Did you do it? Really? Okay, share with Ellie. Yeah. Oh. Okay, we have that. And then. All right, so here are your answers. Tell me whether you agree or disagree. So cosecant of 30 degrees is 2. Agreed? I could be wrong. And then secant of 30, when you take the reciprocal, you do get a radical in the denominator. That one for me is uncomfortable because we never use 2 over rad 3. We just don't. And so if you rationalize that, you get 2 rad 3 over 3. And then cotangent of 30 degrees, you should be taking the reciprocal of this one, not this one. If you had to rationalize the original one, you want to use the unrationalized ratio to take the reciprocal of. And then that just simplifies your work so much more. And so you should have the square root of 3. So any issues, problems, or concerns with that? So that should all be reviewed. Does that ring a bell to you? Hopefully. Okay. So let's flip it over. And all of this should be reviewed as well, with the exception of example 2. Well, these are more difficult reviews. So these are things that you've like, I've had that before, but I forgot how to do it. So part A on example 2, given the sine of theta, I don't know what theta is, but I do know that the ratio of sides is 3 to 5. You need to find the 5 other trig functions. So you've been given 1, we have to find the other 6. Last time you were given the degree. This time you don't know the degree, but you know the ratio of sides. So instead, you've got to draw your own right triangle. I'm going to put theta here where I like it. You can put it wherever you want to, but I like it on the ground. And then because sine is some old hippie, 3 is opposite, and 5 is the hypotenuse. So I know that opposite, my theta is going to be 3, my hypotenuse is going to be 5. I'm left with having to find the missing leg, because I have to have that missing leg to find all 6 trig functions. Now, we can find the leg one of 2 ways. Pythagorean's theorem is way 1, or you could recognize that it's a Pythagorean triple if you know your triples. What is x if you know your triples? It's 4. All right, but if not, we're going to use Pythagorean's theorem. So x squared, you take your legs, square them, add them together, and they should always equal the hypotenuse, in this case 5 squared. So I have x squared plus 9 is equal to 25. If you subtract 9, you get x squared is equal to 16. When I take the square root of both sides, I don't have to do plus or minus, because can x be a negative value? Nope. So I come out with x equaling 4. So that's an important piece. And now you go ahead and find your sine, cosine, and tangent. So this time you're not going to have any radicals. Daniel, you okay? Yeah. So you find all 6. You already have the first one. And it's going to look like this. Sine of theta equals, because we don't know the degree. So just like that one looks like up there. So the hard part about these is finding that missing side. So here's your ratios. How did you do? Good? Bad? Okay. Now I want you to do B. I'm going to get you started on B, because I don't like using secant. I would prefer to take secant and trade it in for what? Cosine. Its inverse is cosine. So the cosine of theta would be what? 3/4. So I choose cosine because that's the inverse function. And so then I can draw my right triangle. Again, I choose to put theta on the ground. And cosine is caught another hippie. So I've got adjacent over hypotenuse. So my adjacent is 3, hypotenuse is 4, and I'm finding x. Don't fall into the trap of thinking that that's a Pythagorean triple, because it's not. X is not 5y. The hypotenuse has to be the longest side, and 5 is bigger than 4, and so therefore x cannot be greater than 4. So now use Pythagorean's theorem to find the missing value. What did you get? Radical 2? Not radical 14. If you mess this up, you're going to mess up all of your ratios. So you should have radical 7. Because 16 minus 9 is not 7. And then when you take the square root of both sides, you get radical 7. So you don't want to be using your calculator right now. Now find your 6 ratios based upon that. Share your answers with those around you to see if you agree. So here are your ratios. How did we do? That bringing back some reminders. Did you do this one in 3-4? Were you given secant? Possibly, as a harder, probably weren't tested on that. You'll definitely be tested on that in this class. Then we're going to solve our right triangles. When the directions say to solve a right triangle, you are finding all 6 pieces to that right triangle. Right triangles have 3 angles and 3 sides. You're finding the measures of all those pieces. And so I'm going to draw a picture of what they are describing if they have not given me a picture. And then I'm going to find what's missing. So they said a right triangle with a hypotenuse of 10. So I'm going to put my 10 where it belongs. It includes a 34-degree angle. It doesn't matter which of these angles you make 34. Again, I like my angle there on the ground. Then you are to find the measures of the other 2 angles and the lengths of the other 2 sides. Well, because it's a right triangle, we already know we have a 90-degree angle. So the easiest thing to find first would be your side length, or I'm sorry, your angle measures. So how do I find the missing angle? And I'm going to call that x degrees. Yeah, they add up to 180, right? So we've got x degrees plus 34 degrees plus 90 degrees equals 180. Could you set up a different equation? Those two, the acute angles in a right triangle, always add up to 90. So you could have said 34 plus x is 90. That's acceptable as well. So if we go with this one, we've got x degrees plus 124 degrees equals 180. What's 180 minus 124? So we get 56 degrees. So there's the missing angle. So that's 1, 2, 3. So we've got those 3. And then our second step, I'm going to name this side here as y and this side here as z, just because I feel like it. You can name them whatever you want to, but I'm going to identify them as y and z so that I know which ones I'm talking about. So if I find y, if this is my angle of reference, is y the side opposite, the side adjacent, or my hypotenuse? This is my opposite. What about z? Adjacent. What about 10? Hypotenuse. So then you're going to set up an angle. Whenever you're missing a side, you're going to set up the following equation. You're either going to choose sine, cosine, or tangent of some degree equals a ratio of something over something. That's where your some old hippie caught another hippie tripping on acid comes into play. But you have to decide, do I want to use sine, cosine, or tangent? Do I have my degree? And then what do I know out of my ratio? So let's decide that I want to find y. So I don't want to use y and z because that's two unknowns. So my only choice is to use y and 10. Y is opposite, 10 is hypotenuse. What ratio uses opposite and hypotenuse? Sine, cosine, or tangent? Sine. Some old hippie, right? So I'm choosing to use sine of what degree? I know my degree is 34 degrees equals, and then write your ratio. My ratio is opposite y over hypotenuse 10. So you are writing and creating an equation. I will ask for that equation on your test. Then if I were you, I would turn that into a proportion and cross multiply to solve. So when I cross multiply, I get 1 times y is y equals 10 times the sine of 34 degrees. Here's where you have to be careful. So write yourself a note. Make sure your calculator is in which mode? Degree. You are putting degrees into your calculator. So for this particular problem, you want it to be in degree mode. You are going to have to jockey back and forth between radians and degrees. But this is important because if you get the wrong answer, that's why you had your calculator in radians. So I want you to go to your calculator. Always check it. So I'm going to go to mode and I'm going to check. And right now I'm in radians, which is bad because I'm putting degrees into that calculator. So scroll, hit enter to highlight the degrees, and then you can put second quit. So then you're going to type in exactly as you see, 10 sine of 34. You do not have to put the degrees in there when it's just plain degrees, and hit enter. It depends on, Math Excel will tell you what they want you to round to. So if you're not told we're going to round to 2, so round it to 2, what does that give you? 5.59, and it's an approximation. So y is approximately equal to 5.59, and that's in units of measure. I don't know what they are, but it's not degrees. So if you put degrees on that, I'm going to have to mark you wrong because it's a side line. Make sure with your degrees that you're putting degree in there because it's degrees. So you've got to pay attention to units of measure. Then for our last piece, as we now know this side, you have to be careful with what you choose to do from here. We could choose to do Pythagoras theorem. We have 2 out of the 3 sides, but what if you made a mistake calculating y? What's going to happen if you use Pythagoras theorem here? Your mistake is going to get reflected in using Pythagoras theorem, so you're going to get z wrong as well. I also would not choose to do tangent of 34 degrees, which is opposite over adjacent, because again, you're using that y that you might have made an error in, that you were not given that. So if you want to be on the total safe side, I'd go and do another trig function using only the information you've been given. So I would use these two, adjacent and hypotenuse. What trig function uses adjacent and hypotenuse? Cosine. So we're going to take the cosine of, I know my degree is 34 degrees, equals, my ratio is adjacent, which is z, over the hypotenuse, which is 10. So again, I'm going to turn this into a proportion. I'm going to cross multiply and solve. So 1 times z of z equals 10 times the cosine of 34 degrees. So you should have already had your calculator in degrees. So I'm going to hit the 10 cosine of 34. And what do I get? 8.29. And that's an approximation. So z is approximately equal to 8.29. And that completes all 6 parts. Now if I want to check, because I'm taking a test, I want to check, couldn't I use Pythagorean's theorem to check my side ratios? Bear in mind that I did round these two, so I might be off. But if I square this and add them together, should they equal 10 squared, which is what? What's 10 squared? 100. So I'm going to take 5.59, square it, and add to that 8.29, and square that. How come I didn't get 100? But I'm darn close. What did I say happened? Yeah, I rounded those two right there. If I rounded those, anytime you round in the middle of a calculation, you're bound to be off, which is why we tend not to round in the middle of a calculation. But all I'm doing is checking. So it should have come out to be close to 100, which it did. Questions on that, solving the triangle? The difference between example 3 and example 4 is in example 4, I don't have to solve the triangle. I don't have to find all 6 parts. I only have to find the part that they're looking for. So this is a true word problem. I know, but I don't want to that. It'll bound to lead to bad things. So from this one it says, from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia. Bless you. They are going to describe to you what's going on. You have got to draw a picture. And it will always be a right triangle for these particular types of problems. So I'm an outstanding artist, as you can all tell. Beautiful building. And here's that point that's far away from the base of the building. So they said that my point is 340 feet away. That's where that distance is. And then it says the angle of elevation. The angle of elevation. They're describing to you the acute angle. Sometimes they might say, let's say that you have a tree that's tethered by a line that's staked 10 feet away from the base of the tree. They might say that the angle the tree is making with the tether line is, and then that angle would be way up here. Or the angle the building makes with the ladder, because maybe they're putting a ladder leaning up against the building. So pay attention to where they're describing that acute angle for the triangle goes. So this time they're saying my angle of elevation. So as I'm standing here at this point, looking up, that's my angle of elevation. Elevation is looking up. I have this angle right here. That is 65 degrees. The question is find the height of the building. So my unknown is here. I'm going to let that be h. You can let it be x. It doesn't matter. Then what I'm focused on is the following. This is my angle of reference. The two sides that I have been given some sort of information on are these two. Is h the side opposite, the side adjacent, or the hypotenuse? This is my opposite. And what about 340? That's my adjacent. So I'm still going to go back to this type of equation here. Am I choosing sine, cosine, or tangent? Which one involves opposite and adjacent? Tangent. So that's why I'm choosing tangent. Do I know the degree? 65 degrees. Equals, the ratio is opposite, so h over adjacent, 340 feet. So I will turn this into a proportion, so here over 1. Cross multiply and solve. 1 times h is h equals 340 times the tangent of 65 degrees. So again, my calculator should be in degrees because I just had it in degrees. But if you're not sure, you can check. So 340 times the tangent of 65. So h ends up being, I'm going to round to 2 decimal places, 729 point what? Yes, 729.13, and that's in feet. Could that seem reasonable? Yes or no? Yes, that's reasonable. Now, all word problems have a sentence answer. And notice that nothing in the original problem was in decimals. So most likely they want you to round where? To the whole unit. So therefore, answer the question as a statement. The height of the building is about, because we're rounding, 729 feet. Because we should also have our units of measurement. So any issues, problems, or concerns with anything on the notes there before we go to our additional problems? Are we good? Did that all ring a bell? Because 100% of that should have been review of some sort. If it's not, then that just means you have to be diligent and come ask me questions. All right, so extra paper. We've got a couple of extra examples.
Do you candle values?
No, it's my wall scent, isn't it delicious?
Christmas.
I know. Well, it's really fall. Pumpkin, sweet pumpkin. Bath and Body. There you go. All right. So, Yep. All right, so example 5. Nobody wants to come into math class and have it smell like mold or, worst case scenario, urine. How this class could smell like that, I don't know. Instead, you walk in and you smell a pleasant pumpkin smell. It's nice. Maybe that's it. All right, so for this question, you're going to find, please write the directions down, the exact value of, and they're going to give you some sort of ratio. In this case, I'm giving a tangent of pi over 4. This would be on the non-calculator portion of your test. When they say exact value, they imply that they don't want a decimal. Now, this particular one you could actually do on your calculator, but you wouldn't have your calculator available. Doesn't this look like one of these special, and isn't this in radians? That's one of the special radian calculations that you were supposed to start to recognize. Pi over 4, pi over 6, pi over 3. So immediately upon seeing pi over 4, you should go, oh, wait a minute, that is a 45-degree angle, and I know a triangle that's associated with that. It's my 45-degree triangle, so I'm going to draw it. I'm going to put in 45, 45, and then what are the legs on the 45, 45? 1, 1, and what's the hypotenuse? Rad 2. So tangent is what over what? Opposite over adjacent. So this is my opposite. Let's, assuming that I'm choosing that as my angle of reference. This would be the side opposite. This would be my adjacent. So the tangent of pi over 4, the exact answer would be 1 over 1, which is equal to 1. If I said the tangent of pi over 3, well, pi over 3, you're going to use this triangle. Pi over 3 is a 60-degree angle, so that's why that's your angle of reference. Wouldn't tangent be radical 3 over 1, which is radical 3? That's all those problems are asking of you. So when it's asking for exact, it wants it in radical form and or whole number form, as this one is. No decimals. Should not need a calculator. Now, if you were to plug this one into your calculator, what are you putting into your calculator? Degrees or radians? Radians. So wouldn't you have to change your mode to radians to check it? So let's go ahead and do that. So I'm going to change this to, change my mode to radians. And then we're going to do the tangent of pi divided by 4, and your parentheses. Then I get 1. And so should you. Are we all okay with that? Okay. So then let's look at example 6. Example 6, you are for sure using your calculator. And it has multiple parts to it. Write down the directions. Evaluate using a calculator. And Math Excel is pretty clear about whether you're using your calculator or not. And then in parentheses, I want you to put make sure you're in the correct mode. That's mode. Looks like mole, but it's mode. Ladies, are we ready? So you've got 5 things here. So you're going to use your calculator, you're going to jockey between degrees and radians. So depending upon what you're putting in the calculator. So you're going to find the sine of 76 degrees, and I want you to round to 4 decimal places. 4. Part B, cosine of 32 degrees, 44 minutes. Part C, the tangent of 5 pi over 7. D, the secant, you should know what to do with that now, of 53 degrees. So you don't have a secant button, so you have to use what? The inverse of secant. So you cannot use the -1 button either. You have to do 1 over. So I'm going to help you out with this one a little bit. That one is equal to 1 over, what's the inverse function of secant? Cosine, right? So we want 1 over the cosine of 53 degrees. So that's what you punch in your calculator. Do not use the cosine to the -1 button. That is used purely to find theta, the missing angle. And then E, you're going to find the cotangent of 7 pi over 8. All right, so you've got 2 minutes. Find a way. What? 4 decimal places. When you're done, you can share them with people around you to see if they agree with you. And I want you to star the ones that you don't agree on. B might be one of those that's tough for you to agree on, depending upon how you put it in your calculator. So here are your solutions since you're so quiet. How did you do? What would you like me to show you? You like E? Before I do E, only because I have B in my calculator right now. Does anybody need to see B? Did y'all get B? Where do you go to put 32 degrees 44 minutes? Your second apps button, right? So you have to go and also make sure you calculate in degrees. This is one of the few times you have to put actual degrees in there. And so for B, that's the way it should look before you put in your calculator. Make sure you end the parentheses. Yes. Oh yeah, on this one I ended up. How'd I get which ones? Yeah. So for C, because I'm in radians, I need to go change my mode to radian. So that could be Y. And so tangent of 5 pi divided by 7. Is that 7? Did I just do something goofy? Why did that not come out? Hang on. Oh, because it didn't change. It didn't change when I changed it. Hang on. Must not have pressed enter. So tangent of 5 pi divided by 7. Now with it in proper radian mode, there you go. So modes and radians. Yeah, and that's usually one of the biggest errors. So when you're getting it wrong on Math Excel, check your mode, double check it. I do it all the time. You're jockeying back and forth and you forget. And then Eli, you had a question on which one? E. So for E, again, I need to be in radians, which I am. I just changed it. So cotangent, the inverse of tangent. So I put this in there. 1 divided by tangent of 7 pi divided by 8. Make sure you end the parentheses. Okay, any problems, issues, or concerns before we do our last problem? You think you've done, let's see, we're not done.
I'm just wondering where my letter.
You might need it. All right, so last problem. Example 7. Find the exact value of theta in degrees and in radians. And they're going to give you some sort of equation. And so the equation I'm going to start you off with is tangent of theta is equal to 1 over the square root of 3. When you look at your ratio, so when I look at the ratio right there, I should see some things that are familiar. If I see 1s, 2s, rad 2s, or rad 3s, it should ring a bell. Don't we have a special right triangle that has a 1 and a rad 3 in it? What special right triangle is that? Is it a 45, 45, 90 or a 30, 60, 90? So immediately I'm going to draw a 30, 60, 90. And I don't know whether I have a 30 or a 60 degree angle here, but it's going to be one of those two. And then here's my theta, because I always put it at the ground. And then notice that tangent, isn't that tripping on acid, OA? So that means that 1 is opposite my degree of reference. So here's my degree of reference. Opposite would be 1. Adjacent would be radical 3. And then what's missing? We don't need it, but what's missing? 2. All that I care about is what is across from theta. Isn't there a 1 across from theta? When there's a 1 across from theta, that means that theta is 60 degrees. I'm sorry, I said that totally backwards. Theta is 30 degrees. Isn't it the smaller one? 1 is the smallest number out of all of those 3. So that means that theta must be the smallest angle. So if theta is across from 1, you have a 30 degree angle. If theta is across from rad 3, then you have a 60 degree angle. So what is 30 degrees in radians? 180 divided by 30 is what? 6. So it's pi over 6. That's the easiest way to remember your radians. Divide 180 by that degree. Done. Issues? Questions? Okay.